So I'll go ahead and get started. My name is Ryan Berg. I am the CSO or Chief Security Officer for a company called Sonatype. Any of you know who Sonatype is? A few. Any of you know or use Java? A few more. Any of you use Maven? Okay, well, Maven was founded by our founder of Sonatype. And he was using that to solve a different problem way back when. And if you go and download stuff from the internet, like you use Maven, and people joke that Maven downloads the internet, it downloads the stuff from this place called Maven, the Central Repository. Well, the Central Repository is something that Sonatype hosts. So who pays the bills for the Central Repository? That is Sonatype. People are like, oh, there's this great thing, and I run Maven, and all the stuff comes downloads from the internet, and it makes my builds and my software great. Well, that's Sonatype. We're like actually one of the largest critical infrastructure type companies that nobody really knows about, right? Because if the lights went off, well, I mean, I guess you could eventually get it from my Biblio and people would figure things off. But when Central, there's a problem in Maven Central, like it's known instantly. People are like, oh, it's on Twitter, like, hey, I'm not seeing my components, my build broke. Yeah, well, that's because it's something it's sort of invisible, like everyone sort of expects it to be there, like the internet, or maybe Facebook nowadays. But when it's gone, people notice it. The interesting thing is that, so we've been doing a lot of work in Sonatype and looking at open source consumption, primarily because we have great insight into what happens inside of an ecosystem like Java, right? It is the world's largest repository of centralized open source components. So there's roughly, I think there's like 650,000 different individual things. So if you think of a warehouse, there's like 650,000 different parts in that warehouse. They represent about 65 or 70,000 different kinds of projects. So each project can have multiple versions of that. And what we do is I spend a lot of time looking at data. I had a joke the other day. I was talking to our CFO. I said, oh, I dream of numbers. He's like, I got a position for you. I was like, well, I might not be good at finance. My wife runs the bills at home. If I run the bills, I'm like, I'm at the macro level. I see the big picture, these little details, bills getting paid. I'm not really good at that. Actually, I think American Express has been calling me every couple days because my expense account has gotten a little out of control. So we did this survey with roughly about 3,353 different people looking at how organizations view and look at open source, especially when it comes to open source security. It's been rather an interesting year for open source security. I mean, I've been doing application security for a long time, and it's been a really interesting year as far as open source, because there's been some very big moments. Like, how many people have updated SSL more than once? Yeah. How many people actually updated Bash? Right. Yeah. So it's like all of a sudden it becomes a very real thing for a lot more people that really they're like, oh, okay, well, I'm using all this open source. And if you talk to some more organizations, well, do you have an open source policy? I'm like, oh, we don't use open source. I'm like, do you do software development? I mean, really, you can't really do software. I mean, maybe if you're doing a specialized embedded system and you're using QNX versus GCC, you might be able to get away with using very little, if any, open source. But outside of that, it really is, the train has left the station. These stats are old. I mean, Verizon report, you can read any report says, the application stack is the most widely targeted stack these days. In Maven Central, just one repository, we see roughly 13 billion requests of stuff downloaded in, I can't even count the number of organizations, right? Every organization across across the globe is downloading things on a daily basis from Maven Central. We argue that a typical modern application, 90% of it is stuff that you didn't build yourself. I mean, I used to do this an example. I mean, I could probably do it here because there's probably more developers here than some of the other places I speak. But I've got an example project in IntelliJ. I was doing some work with Madison, Wisconsin on some data analytics. And so I wrote a basic web service, right? So what do I use for web service these days? Well, I use Drop Wizard because it's really neat and it's really easy to write REST-based services. Of course, Drop Wizard has an embedded Jetty database inside of it. Well, it uses Jackson for passing its REST messages across. And if you look at the dependency tree, right? I wrote maybe 500 lines of code. But if you look at the Maven dependency tree of what's in my application, I can't even count. I don't even know what half the stuff is. Like, why is this in here? I don't know. It must make it better. It builds. We no longer really even know what's in our software. I mean, I'm a software security guy, and I have to cringe, right, every time I hit build, because I'm like, I know I should be really paying attention to all the stuff that's in here. I'm just going to assume it's okay, right? Because everyone else is using it, right? And we do that, right? We do that on a regular basis. We are becoming so numb to the fact that it's gotten so complex. There's so many things that, well, you know what? I'm just going to assume. And I was just right before this talk, I'm back there. I'm thinking because I was like playing around with Docker, and I'm like, wow. Not only do we not know anything what's in our software, pretty soon we're not even going to know what's in our infrastructure anymore, right? Because I'm going to be downloading Docker playbooks, and I have a problem with forking repos. Right? It's like, oh, I see this good thing on Git, and I'm like, okay, I'm going to fork that repo so I can take a look at this. Well, if you look at all the playbooks, they're all in Git. If you go on Puppet and Chef, there's repositories all over the place, and I get halfway through what it does, and it links to some other repo and some other repository and some other playbooks, and next thing you know, I'm like, okay, well, I'm going to try it. And okay, well, it looks like my VPC was set up correctly. That's got to be an okay kind of thing, right? I mean, it's just as scared I am about our software. We see the same thing in infrastructure, right? As we move DevOps, we talk about DevOps as a way to accelerate your ability to deliver software in a production environment. I am just as scared about our not knowing anything more about our infrastructure than about our software, because we're leveraging all this work that we really don't know how it works. It's like it's magic. You know, we talk about unicorns. I mean, software has become very magical. I remember when I first discovered dependency injection, I'm like, wow, this is awesome. And then when I first had to analyze an application from a security perspective which uses dependency injection, I'm like, man, this sucks. Because it's like trying to figure out what the application does. It's like data just magically appears. JSR 330, it's like the bane of my application security existence. I'm like, why did you create that? As a developer, I'm like, this is so badass. You know what? If we look at it, our organizations haven't really even caught up, right? Most people don't even have any controls on what components are in their applications. No controls at all. If you have any control, maybe you have a spreadsheet like says, okay, you're allowed to use these software packages. And then you go ask the developer and saying, what are we using? Did you know you have a list? Like, a list? Yeah, there's like these guys, and occasionally they come around and ask us for these inventory stuff. We don't pay attention to any of that. We just, put the Maven dependency in our palm, and it goes. In application security, most application security projects aren't even looking at open source. They are so buried in your own code, ask them to say, well, you're looking at all these other packages. Right? How many people actually did an audit on OpenSSL? Right? The vulnerability existed for 20 years. Right? You've been using it. It's in your software. Did you look? And we're like, everyone's like, oh, well, it's the many eyeballs theory of open source. Right? Well, hey, with all eyeballs, all bugs are shallow, right? Well, no one's looking. Right? That's the reality, right? Nobody's looking. Just because it's open source doesn't mean that someone is looking, or that the people that are looking are going to tell you when they found something. Right? That's the other important detail here, right? Because the people that do look, there is a real market for that. I mean, Charlie Miller, those of you that know Charlie Miller, does a lot of hack-to-own laptops and did a lot of stuff with Macs, and then did the whole hacking cars and automobiles and all that kind of stuff. Brilliant, brilliant guy, right? But he's on record, I think it was, I can't remember which Black Hat it was or which event, but he's on record saying, yeah, I sold 0 days for 6 figures, right? There's a real investment there. People will spend time, will find things, and when they find things that are really kind of neat, they may not necessarily tell you, well, are you looking? Reality is, they're not. 77% have never banned a component. Like, oh, you should never use this. I remember when I was doing, I built a company a couple years ago that did static source code analysis. This is not a static source code analysis talk. If any of you have ever run it, I'm sorry. Sorry, I'm gonna get that out there right now. But I wrote one, and I used to talk about people banning, I can't remember the call. But having a list of banned APIs in your source code. And I said, how many organizations actually ever banned an API? Sprintf versus SNPrintf. Most people are like, oh, okay, well, maybe we've got some coding standards, maybe we do this, but how many of you have ever banned a component, right? You should never, ever use this. Struts version 1. I'm just saying. Not that I have anything against struts, right? I am a big proponent of open source. I love open source. I may pick on certain versions of certain projects because, honestly, now is not the time to be using those. We were talking about one jug a while back, because struts, much like OpenSSL, has had some issues. And we were talking about in a jug, we're like, okay, how many people use struts? And a bunch of hands go up, and they're like, okay, well, you realize that if you're not on the actual latest version of the latest version, then you're likely vulnerable. And that guy was like, we're like, well, so what version of struts that you're on? He's like, 1.3, and there's like a collective gasp in the audience, like, he's like, what do you mean, what? He's like, where have you been? Struts 1 is like long since dead. I think the developers have all packed up and gone home. And he's like, oh, well, the application just kind of worked. Right? We do that. Right? I guarantee you, I'm going to have some examples that, when I talk about aliens in your software, I've got some examples of things that I guarantee you is in every one of your projects. Because it's like we talk about our own technical debt. Technical debt compounds with the components that you're using. It's compounding. Like you're building stuff, and you're building your own technical debt. Meanwhile, you're like not updating your versions, or lo and behold, you've got like 6 different versions of Log4j in your software, and you wonder why it doesn't build sometimes or it doesn't run. Have anyone ever run into that problem? Right, where you got this dependency nightmare, right? And you're finding out, oh, wait a minute, it works sometimes, and sometimes it doesn't work. It just happens that it's picking up a different version on the class path, even though they're both in your build, and you get these weird esoteric errors. Sometimes you're lucky and you get the Java class name mismatch. Okay, I know something's wrong here. So you start messing with your compiler settings. You're like, okay, well, is this really Java 5 or Java 4? And eventually you may find that you've got way down deep. You're like, why do I have like 2 different versions of Log4j? And it just happens that it happens on this machine and not this machine. Like I said, I'll be lucky if I get through all 45 slides. These slides will be available. I won't go through every bullet. We talked a little bit about this. The interesting thing here is when we started Maven Central, this is what component development looked like back in 2007. Maven was actually earlier than that, but it wasn't until we realized that we needed a place to go get stuff. Right? It wasn't just the dependency resolution. Right? The problem that Maven was trying to solve is that when I wanted to use open source, I had to go download this open source component and figure out how it builds. So I want to use Log4j. So figure circa 2003. I want to use some open source component. Okay, I want to use this. I want to have to write my own logging framework. So I'm going to go download it, read its build instructions. I'm going to use Ant. Oh, I love Ant, right? Okay. Oh, wait a minute. It needs this other thing. So then I have to go, what's this other thing it needs? So I have to go figure out, go to its website, download it, and figure out how it builds. And then it needs this other thing. So Maven was all about, I don't care how all this stuff works. I really don't want to care. I just want to use this thing. So when I want to use this thing, give me it and give me everything that it requires to run. Don't mess my head up with the details because I got enough problems to worry about. The problem is that in order to do dependency resolution, you need a place to get the stuff in the first place. That's where Maven Central came. Like, oh, we need a central place where you can download these things. So when you have a dependency tree, that all it depends, you can sort of download it, and it sort of comes with it. I sort of think of like the Roche Motel. It's like, oh, this great thing, and it's bringing all its friends. Right? We know it's essential, right? Who does big data that is building a new Hadoop? Okay. Are you using Hadoop or are you building a new Hadoop? What's that? Is it going to be open source? Good luck on that. I know some guys at Facebook, and Facebook have already done, so Facebook has already moved off of Hadoop and moved on to Presto. Anyone have looked at Presto? So if you're doing big data stuff, so Presto was, the problem with Hadoop was, the queries could take a very long time, right? So Facebook, well, we got petabytes of data, right? I need queries that return, can go across petabytes of data and return me answers now. So they wrote Presto essentially is a real-time analytics engine on top of that. Actually, no, so Jason Van Ziel, who was our CTO, was working with the guys at Facebook to help them with their build infrastructure. So, Presto, all I'm saying is that there's very big companies that deal with petabytes of data that are already onto proving open source technologies on the next set of problems. So unless you're already there, I highly don't recommend you going down the path of writing it yourself. Much like, do I want to write my own logging framework? I've got how many to choose from? I would Log4j, well that's, they kind of sold out. I'm Logback. All the cool kids are on Logback these days. But it's essential. I can't build my applications without using it. Or if I am, someone should have my brain examined and ask me, why am I wasting my time writing something that someone has already written that's probably better than what I could write in less time? The interesting thing is that when this survey first came out, right, we asked the question saying, how many organizations had a breach attributed to a vulnerability open source? Before Heartbleed, it was 19%, right? After Heartbleed, everyone's oh yes, there's this new thing, oh, I didn't know. Oh, holy cow. We are still seeing this sort of long tail of that. I see all these sort of issues have a very long tail. You've got a lot of rapid responders. Heartbleed was the first sort of wake-up call, oh, we've got to fix this because my website's on this list. And people are already taking advantage of that. But when we talk about embedded systems, medical devices, it's even harder to is there an upgrade that's even available? Do you even know? These things should be a wake-up call that says, do you even know? Because half the problem with these two issues was, am I exposed and where? Right? The patch was relatively simple. The problem was identifying, well, all right, well, where is it in my organization? And these were pretty big things, right? Even though OpenSSL is open source software, it was really almost in this case, the patching was reduced to updating a binary of your servers using apt as an example, or RPM package. It wasn't, do I have to link into these new libraries and some software? When you look at an example of a library like Xstream or Zayland, both have had issues. That's a very longer tail kind of thing, because you have to am I using this library? And where? And half the problem is that other libraries may be using it and you don't even know that you're using it in the first place, right? I already told you that nobody's looking, right? 1 in 10 had a suspected open source related breach in the past 12 months that they were actually willing to admit. It's not all that uncommon, but people really aren't looking. It's very easy to look at application-style attacks like cross-site scripting and struts and focus on the application that you believe is your weakest spot, but don't really realize that you have a much bigger foundation that you're not paying any attention to. I think some people say, well, we care, but we really don't. That is the bane of application security. Everybody says that they really care about application security, but when you really get down to it, not so much. Yeah, I like features. Features win the day. Features, more software. Application security, yeah, we've got those security guys to do it, and they're already overloaded, right? So even though 56% say they have open source policies, right? They say they have a policy, right? 78% have never said they've ever said you can't use this anymore. I got some great examples of libraries that you should just never use. Let me tell you, if a library is had one release ever in its history, and it's 7 years old, I'll take a wild guess that you might want to pick a different one. I mean, I don't know, just me, but if it's only ever had one release in its history, and that release happened 7 years ago, chances are there is nobody who understands that. Nobody's looking at it. And if there's a problem, good luck. Just saying, there are some opportunities to ban things that, you know what, I might need a policy to just address these kinds of things, right? But even more interesting is that even though they say we have a policy, it's often not even addressing any sort of security. It's all licensing. When we talk about open source, a lot of the focus is on licensing. And that's not to diminish the fact that licensing is a big deal. We care about licensing. Should I be using GPL? Well, if I'm running a SaaS, okay. If I'm redistributing code, maybe not okay. If it's a GPL, then I have to probably not a good idea in either case. But 41% say it must avoid known vulnerabilities. This is a very basic thing, right? But even to say, 41% say we must avoid using libraries with known vulnerabilities. Only 21% say, well, we actually have to prove that we did it. Sometimes I have to sort of scratch my head. And the interesting thing is that even though this is a survey, we all have our own opinions on surveys, right? I talk to organizations and I see this on a regular basis, right? Oh yes, we shouldn't be using things that are vulnerable. But we have no way of actually determining whether we're using those things in the first place. Okay, which one do we think is more important? Saying that we shouldn't use them or actually be having a way to verify that we are in fact, actually not using them? The interesting thing about developers is that developers just aren't looking at security. Right? How many developers in here? I mean, when I qualify developers, like, okay, like this week I'm like writing code this week. Oh, that's awesome. I've gone to so many security conferences. We have people like have to write code, and like this is not like, okay, well, I wrote a batch RC like startup script. Like, I'm just glad to see developers, right? How many of you actually look at NVD feed on a regular basis? Interesting. How many people even know what the NVD feed is? All right. Oh yeah, one. Okay, so there is this national vulnerability database sponsored by MITRE. Comes out as funding from the DHS, which on a regular basis says, hey, guess what? New vulnerability in this thing. This thing could be new vulnerability in Struts version 1.4.3, or new vulnerability in Zayland or Xtreme or whatever. And it comes out on a regular basis. There's a feed, you can subscribe to it, RSS feed, et cetera. Regular basis, and it says, hey, there's a new vulnerability here. Now, if you as a developer is not looking at it, guess who I can guarantee is paying attention to it? Well, I know I am, and I'm a security guy. I know that there are other people, because when you see that, oh, wait a minute, like Microsoft just had, I was reading this morning, like Microsoft had like a new 0 day that's already been exploited in the wild. Well, guess who's like paying attention? When you talk about all these exploit kits or Metasploit, well, when there's a new vulnerability, the first thing you do, especially in open source, like, oh, there's a vulnerability here? Oh, go download the code. Oh, okay, here. Oh, Metasploit. Oh, ready to go. So if you're not paying attention to it, well, guess what? The rest of the world is, or at least some part of the world is, and that part of the world is not necessarily a good, conducive part that you want to invite into your organization. But they really don't pay attention. That goes back to the, yes, we care, but yeah, not so much. The interesting thing is that we also have this sort of handoff to, it goes into production, but we don't really know the difference what's actually in a production versus in our development environment. We talk about, we do a lot in Agile, we do a lot in DevOps, but we don't do enough to say, do we actually have a bill of materials of what's in our software? Very simple thing. Do you know what's in your software? I guarantee you most of you have no idea what's actually in your software. So that when there is an issue, you can ask the question saying, hey, I need to go recall that. Right? What happens if there's a problem in automobile manufacturing, right? There's this thing that just came out, right? These airbags, right? Granted, the website crashed, but let's get over that part, right? Because probably you guys didn't work on it. But the website crashed. So there was a place you could type in your VIN number of your car, and it would say, oh, yeah, you got a problem. Can you do that with your software? Oh, wait a minute. There's a problem in struts. Oh, let me type in struts. Oh, it's in this application, this application, this application. I need to go notify these 4 development groups to tell them that they need to go fix this thing because you understand what's in your software. You don't understand what's in your software because I guarantee you, okay, all right, I don't think I have any cash in my pocket. Normally I have cash in my pocket. If I had cash in my pocket, I will write you a check. But if you can actually prove to me that there's one person in this audience which can actually deliver a bill of materials of every application in the organization, I will give you $50. You got to see me after. We'll talk about how we can verify that actually exists. But I will give you $50 if you can do that. I've yet to have anyone take my $50. It's ranged from 50 to 100. So it depends on how much money is in my pocket, but I'm kind of poor these days. I told you American Express is after me. So which way are the fingers pointing? It's like, who thinks that they own this problem? Application development said, oh, well, okay, who has responsibility for tracking? We just saw in here, it's like, okay, well, nobody in here is, but a lot of developers. 40%, okay, well, 18% security. A lot of times I see a lot of this. Okay, well, no, the minute there's a security thing, it's like, we got a security team for that. The security guy is like, oh, this is an application security problem. We got an application team, right? They got their own security specialist. Both guys are going like, oh, well, no, it's licensing. Oh, this open source thing, that we got legal. Oh, no, this is a production problem. Oh, yeah, that's operations. Luckily, there's the 13%. It's like, you know what? Let me be honest here. I have no freaking clue who's got the ball on this. This actually should be bigger. These people are the people that actually don't know and think that someone else is having it. These people say, oh, well, I think I got the ball, but I'm not quite sure. But most people have no idea who's actually in charge of understanding what's in their applications. Everybody thinks it's different. I mean, the bigger the organization, the worse it gets. You talk to smaller SMBs, like there is no such thing as security and operations and app dev is like they're the same guy. Like, oh, wait a minute, I got to put my security hat on today. Oh, I hate myself. Oh, take that hat off. I'm going to be a developer today. Oh, this is just so good. Operations, when are you going to get off my back? It's already working. The problem is that we don't really have a way of codifying this in a logical sense, right? How many organizations actually have an open source policy? Right? In 2012, we said 51% said no. 2013, it was 57% said no. 2014, it actually went down, so only 43% said they have no policy. But policy is only part of the problem, right? Because we actually have a policy, everything's good, right? Do you actually follow your company's open source policy, right? Okay, well, so the amount of people, the number of people that have policy went up, right? The number of people that actually follow that policy went down. Okay, so more people are creating a policy, but less people are actually following that open source policy, which tells me something is fundamentally broken here, right? It's great to say that you've got an open source policy. I love the words you can use, open source governance and all that great stuff. It's all great policy type language. But when it funnels down to actually getting work done, that usually goes right out the window. I'm glad we've got a policy, but you know what? This build's going to break, and I can't begin to adhere to this thing that came down from Mount Zion, so the build's going to build. And the other thing is that a policy without controls, as I mentioned, is just words. It's words on a paper, right? So how well these organizations control which components are used in development? 39% they have some standards but not enforced. 36% said there are no standards, so each developer chooses whatever they want. And 25% said we're completely locked down and we can only use approved components. So anytime someone says that, that's the time that I pull them aside. I say, we should have this conversation. I'm sure you probably believe that actually exists, that we've completely locked down and only use approved components, but I can guarantee you that you don't. Because your notion of what a component is and what approved is means two different things. We went to one organization, a bank. They're like, oh yeah, we use, so one of the things that in Java, you can use a caching proxy, so you're not sort of downloading the internet, you're downloading from your own proxy. You can use Archiva, Artifactory, Sonatype. We have Nexus, which is one of the most popular. That's a little silent plug here. But the point is that we went to one organization. They said, oh, well, we use Nexus. Everything goes through Nexus, so all our developers go through Nexus. And then we said, oh, okay, well, what about all these IP addresses which are downloading directly from Central? And they're like, well, no, we've got this central repository. I said, yeah, I'm glad you've got this repository, but what about all these other IP addresses which are downloading things directly from Central? They're like, oh, yeah, let me get back to you on that. So they think they're locked down, but they really don't have the ability to really understand, well, are they really locked down? How locked down are they? Is it really being effective? Right? Don't worry, this is where we got it, but who's got it, right? Yeah, somebody's got it. When there's this many people that think they got it, nobody's got it. And then, of course, well, do I care, right? How would you characterize your developer's interest in application security? It's a top concern, 2013. It drops by half in 2014. They're spending a lot of time here, but they're caring less and less. This is sort of a big problem. I was actually watching a video the other day of on a guy, I guess who was a co-founder of Wufoo. Anyone heard of Wufoo? So did you ever see that video he did? Like he did this presentation at Stanford. Probably look at it at YouTube. He talks about startups and it was really good video, well worth your 36 minutes. So Wufoo had this whole thing where they had a problem, or they were a small company and they're trying to scale it to a number of organizations. They create these web forms for small businesses, easily to make web forms. And one of the things that they want everyone in support, so that their engineers clearly understood the problems that their users were having. Because they realized that, well, we don't have a big organization. We can't have a separate support organization. But more importantly, right, when a developer picks up the phone and hears a user, an end user, complain about something that they wrote, what do? They go fix it. Like, oh my God, did you hear that guy? He was like crying because of this feature that I put in. I thought I got to go fix that, right? Developers don't care about security. They're not paying because it's not part of their world. It's just security guys, right? We have to get out of that. We talk about DevOps as collapsing these environments, so it is a shared responsibility. We have yet to figure out how to break this mold with application development and security. We still think it's someone else's problem. We're not going to, I believe, I've got a lot of opinions, but I personally believe we're not going to begin to sort of crack this application security nut until we make security a part of the application development problem, much like support. Right? So when we select components, which characteristics would be most helpful? Right? The number one concern is, well, it's features and capabilities. Right? Then maybe we care about licensing, then we care about compatibility, and then 43% say, well, then we care whether it has any known security flaws. Right? Which sort of goes to the whole thing. Well, hey, I don't really care about the security piece. If it has this feature, if it works, I'm going to ship it. That's what I need. Right? The security thing is really such a drag. Right? What application security training is available to you? Right? Oh, well, we've got e-learning, instructor self-test, secure coding. You get down here like, oh, well, we don't have any secure training. If you talk to the guys that have had the pleasure of using dynamic and static application tests, maybe they're still your employees or they're on monster.com. I don't know if anyone uses monster.com anymore. I may be aging myself. But these are like, it's just not a part of my daily concern. It really is someone else's responsibility to tell me whether the application I wrote was secure or not. Doesn't that just sound like fundamentally wrong? Much like the support problem. Like, oh, well, shouldn't it be your responsibility to understand whether something you wrote and you were responsible for has a security vulnerability? Shouldn't you know what's in your software? I mean, if anyone's going to know what's in the software, shouldn't the developer know? And if he's already pointing his finger saying, well, that's someone else is going to tell me whether that's okay or not. that points to a bigger problem, at least in my mind, right? We already I talked briefly about this, right? App dev runs at agile and DevOps speed. We all like the new buzzwords, right? But at what point in development process does an organization perform application security analysis, right? Well, if you look at how many are actually automating any of it, very few, right? They're doing it in various places, but they're spending a lot of time in design and architecture, a little bit more time in development. Once it gets there, it gets less and less and less and less, right? None throughout the process, right? 25% are doing something in production. Nothing in production. I mean, to me, that's a scary piece, right? Because this is the area that is at most at risk. What's actually in production? 25% say, application security. I'm going to wait until it hits the news. Oftentimes I talk about policy. People do focus on the license piece, right? But here is, hey, are open source licensing risk a top concern, right? Well, 59% say no, 41% says yes. It's not too surprising. It's roughly 50-50. Kind of depends on the business that you're in, that people think about the licensing of open source. I'm actually more concerned about things like GitHub, because there's a tendency in open source to just throw things up on GitHub, right? And star things and fork things. And a lot of times, there's a lot of repos up there that have no license. And that's a little worrisome for me, because because we all know what no license really means, right? License is the contract which gives you the ability to use it at all. It tells you what your rights are to use that piece of software. No license means you have no rights to use that software at all, right? Because license doesn't trump copyright. So the fact that there is something that has no license, it's not like, oh yeah, well it's no license, it was on GitHub, it's like free. Or maybe it's free, but you have no legal right to use that at all. No license applies, you have no legal right, because it's the license that gives you any legal rights at all. So how much time do I have left? 8 minutes. Perfect, I think. So these are the things that I talk about as, these are the components that I guarantee you are in your software. So I talk about this as the infector, right? Where this is a thing that everything else depends on, or you've got a vulnerable component that is widely used. So in this case, it happens that Spring, popular framework, some of you might actually use it. It has a vulnerability from note to date, 2011. So this is just looking at Maven Central. There are 8,781 other things that depend on this. It's been downloaded just in the last 6 months, over 7 million times. It has a CVSS score, which is a sort of risk ranking from 1 to 10. Although, don't hold too much candle in here, because I've completely rooted machines that have a CVSS score of 5. It just happens that the vulnerability was like 6 or 7 years old, and so new techniques said, well, when it was out, it was a 5, but now with new techniques, it really should have been a 10, but they don't really go back and adjust scores, because nobody really pays attention to this anyways, because you didn't even know what MVD was. So, hey, you're learning something here, right? CVEs, this is what they are. This is how they get classified. CVSS score, how risky is it? Mean time to repair is a calculation that I've been doing some research in, and just in Maven Central, which is how long it took one of these projects to fix this issue. 229 days is the average time it took a project that was using this to realize that it was using that and actually fix it. The mean time to repair, once this stuff gets in your software, it's like really bad. The average mean time to repair of CVSS scores of 10, so 10s are like, hey, this is like root 0 day, you should get rid of it. 390 days, 390 days, over a year. These are the number of unique organizations that are, so I know that there are 72,000 organizations which have been downloading this thing, which is 3 years old and is known to be exploitable. And it's everywhere, right? 8,781 projects depend on this particular component, which has this vulnerability, right? A vulnerable component, this is the imposter, or I like to comically refer this as the life of the party, right? All my friends are using it, right? This is Xerxes, very popular one, malformed XML input. You know, anyone have been hit by malformed XML issues? I mean, so if you haven't been, if you're using XML, doc encoding, all that kind of stuff is just being like completely torn up and ripped apart. Right, if you're using any sort of doc coding, Zaylan was another one. So Zaylan, another interesting one, because I actually had to write a patch for Zaylan. Offline, I could probably talk to a little bit more, provide a little more color on what happened there. But these are particularly interesting because everyone's using XML, and it's just like fun. You can arbitrarily run any command. So these things allow you to call static code. So you call static code, load code, it's all like a huge blast. But everyone's using it. 119,000 different organizations are using this particular vulnerability. Fun one. I've forgotten my security vulnerability from many, many eons ago, right? So look at this one, right? This is the one, 2003. But the thing that got me about this one was that it's from a Java plugin 1.4.2 for applets. Really? But 119,000 different organizations are still using Java 1.4.2 applet with a Zaylan processor, a vulnerability of 6.8. Download count, a little bit less. It's not as popular from a number of dependent components, but a lot of people are using it. And this is, what, 11 years ago? The undesirable, this is one of my sort of favorite, right? This is one that has neither a declared nor an observable license. It just has no license. I can't verify that it has a license because it doesn't declare it. And when you look at the source code, either the source code is not available anymore, which does happen, right? It's the internet. Things do disappear. We talk about that in cloud, right? There might be some cloud talks like, oh, well, what happens if the cloud disappears? And your backups are in the cloud. The backups of your backup is like in the cloud. I can't wait for the time that happens, at least if it doesn't happen to me, that I don't have to be in the conversation with my CEO or CIO and be like, well, what happened to the data? Like, it was in the cloud. No, but with the backups, it was the cloud. We trust the cloud. Trustmonster.com after that one. Right? No license, no worries. I talked about this, right? Its last release date was 2006. Still 8,000 unique organizations, still downloaded a relative amount of time, 802,000 different times in the last 6 months. But it has a reasonable number of dependent components, which is pretty interesting. The reason why this one has no license is because this version is not declared, and you can no longer get the source code for this version. It's like disappeared. The unproven, a popular component with declared license but no proof of source. This one is, it's like I say what I am what I am, right? You can't verify that what I say I am is accurate, which is another interesting thing, which is the ability, and this is like a problem for another day, but I'm just going to tease it out there. So we've got these binaries, and we've got this source code, and there's a secondary problem that says, does this source code produce this binary? Not sure. Most organizations can't do that with their own source, right? Their own applications. This is not a new problem. It's like, okay, I got source code. How do I verify that this source code actually built this binary and there's nothing different between what the source code says it is and the binary actually produces? But when you don't have the source code to actually even attempt any verification, well, you kind of have to hope and pray, right? This is the living dead, right? This is the one that, like, if you're going to ban anything, this is a good one to ban, right? One release ever, right? Ever. I mean, how many regular expression libraries are there out there these days? There's probably like at least a dozen, right? The fact that there's still 500,000 downloads of one that was released in 2005, and it's only, I mean, this was the first reference implementation of reg expression parsing by Jakarta Commons project, and it was released once, and that's it. This is just one example. I guarantee you that if you were to go look in your applications, you've got at least one component of every single one of these categories in your software. I got a completely other different talk, which talk about the expanding horizon of how these things interrelate. You look at your application, the dependency that it explodes is just mind-boggling. I look at those of you that use NuGet, so I'm doing a lot of work in NuGet. The NuGet gallery, a lot of repositories, all repositories aren't equal. Right? A lot of repositories are still sort of trying to figure out what it actually means to be a repository. Like we were talking to the NPM guys, and it was only like 3 months ago that NPM realized that having components which are idempotent is an important thing. And I'll explain that a little bit, because if you download something that says it's version 1.4.1, it's really important to know that 1.4.1 can't sometime in the future be something different and still be 1.4.1. That could be a problem, right? It's saying that it's a particular version and it's changed, but it's the same version. Well, a repository shouldn't allow those things to occur. Well, up until like 3 or 4 months ago, NPM was not like that. So you could just change things if you want. As a developer, like, oh, you know what, I made a mistake. I'm sorry, I made a mistake, but I don't want to change the version. I'm just going to republish my code as that. I mean, that's just like a bad practice altogether. And even if you're doing it in your own software, you should just completely stop doing that. Releases should be, I shouldn't say should be. I'm now going to use the word must, and I very rarely use that word, but releases must be idempotent. You cannot say that you made a mistake, re-release the software with new bits and call it the same version. It's a different version, and it should be categorized differently because of that. With that, there's some marketing stuff. You can get your own risk assessments, and hopefully you've learned some more about open source. You can raise the bar of your applications, which is banning avoidable risk and remediation. Important thing is that this problem is not getting smaller, it's getting bigger. I'm just as worried as I mentioned earlier about these other communities and environments that are popping up. Like I look at, say, Ansible, Gallery, Docker, and Puppet. There's just so much stuff being contributed at such a rapid rate that it's getting very difficult for not only you to understand what's in your software, but how that software is actually being deployed. And I was thinking, interestingly enough, well, what would it take to hide not that I would ever do this, hide a malicious attack inside a series of recursive Ansible playbooks? Probably wouldn't be that difficult. Right? See a bunch of playbooks, develop a bunch of roles, throw some stuff over here, over there. Next thing you know, I'm just downloading some stuff that I didn't know is now running in my infrastructure. So just as you should be paying attention to what's in your application from a source code perspective, if you're moving into the whole Ansible, Salt, Puppet, and you're using these community-derived resources, I know that if I'm thinking of that from an attack, I almost guarantee it's already there. I haven't found any evidence of it, but I know that I'm not the only twisted soul that thinks about these things and gets scared and keeps a light on at night, that there are other people out there doing the same thing. With that, I think I probably have about like 10 seconds, well, less than 10 seconds. -3 minutes for questions. Anyone? Bueller? Yes. So there is a feature in Nexus Pro called Procurement, but the important thing to think about is that it's not locking them from getting in, because they have a state of themselves, right? Because we think of that as sort of the golden repo fallacy. Right? People believe that, okay, I can have a repo that's only going to ever have good stuff in it. The problem is with that is you have to be able to reject stuff out of the repo in the first place. Because when a new vulnerability comes out of something which was already brought in and said, oh, this is great, then you have to have the ability to understand that that exists so you can either, one, get it out of the repo. The problem with that is then it starts breaking builds. So even though procurement allows you to do that, we have a separate workflow we talk about from a component lifecycle management standpoint, which is to get you down a path where the golden repo is not your problem. Your problem is understanding where it is and then being able to prevent it at certain gates in your lifecycle. And I think, yeah, I'm probably already over late, and it's like there's going to be a break, and people are going to start drinking soon. So, but I do take cards, and I don't know. There's an email. It's rberg@sonatype.com. Shoot your questions there. I'll try and get to them. If it's a good one, if it's a bad one, I just ignore it. Thank you.